We're going to focus today on electrical current and resistance. Electrical current is the rate of flow of electrical charge. Now, this flow could easily be disrupted by several factors that we call resistors or resistances. Entry into the park illustrates this beautifully. First, you have to enter through the turnstiles where your ticket is checked. After that, the flow passes through the first restriction or security check. Recall that current is the rate of flow of charge. Now, in 1850, George Simon Ohm made a very, very important observation. What he noticed was that as the potential difference increased, the current increased. Now, he did this without marbles and, magnets on a metal track here. But what he made, that conclusion, was extremely significant because what he saw was that as the potential increased, so did the current. Well, that makes perfect sense from a gravitational standpoint, but what his contribution was also that observation in an electrical standpoint. Well, all electrons, all electrical charge travels through conductors. All electrical charge is traveling through conductors. And therefore, the conductor and its properties will affect the rate of flow of that charge, the current of that. And so what he recognized was that as the potential difference increased, so did the current. And he defined a very specific ratio. This ratio that he did, let's go over here. This ratio George Simon Ohm, right around 1850. Okay? 1850 recognized that the ratio of the potential difference to the current was defined as resistance. As charge passes through a conductor, the properties of the conductor affect the flow of charge. But this ratio remained constant. Rather, as the potential difference increased, the current increased. But the properties of the conductor collectively are called resistance. And so, he defined this term resistance. What he observed, and resistance is symbolized with a capital R. Now what he learned was this. He took a bunch of materials and he plotted a potential difference with the current. Well, what he recognized was that he developed a curve, a linear function that looked like this. That as the potential difference increased, a corresponding direct proportional change in the current was reflected. And so the slope of this line reflects an understanding of the resistance, which is a reflection of the properties of the material. Now, this type of curve, a curve, where over a large range of potential differences, if this curve remains linear, we call the material ohmic. Okay, so what we're saying here is, or what we're defining is, an ohmic material. An ohmic material. And an ohmic material is any material through a large range of potential differences, maintains a constant ratio between the potential difference and the current. So through a large range of potential differences, if this ratio remains constant, then we define the material as being ohmic. Well, we're going to focus on only ohmic materials in this course. There are materials that do not remain linear, where this ratio doesn't remain constant as the potential difference continues to increase. And we call those materials non-ohmic. And the class of materials that are called non-ohmic are called semiconductors. They conduct only under certain conditions. They conduct only under a certain range of potential differences. And on others, they don't seem to conduct as well. So the resistance varies with the change in potential difference. And so we are only going to stick with ohmic materials. Materials through a large range of potential differences maintains a constant ratio between delta V and I. Okay, well, we know that charge flows through a conductor. And we have now defined that all the conductors we're going to talk about maintains this constant ratio. Well, if this ratio remains constant, then what we can do is, and what is done is, define a very important relationship that is called Ohm's law. Ohm's law. Now, once again, Ohm's law speaks to the ratio of the potential difference to the current remaining constant through a large range of potential differences. Well, nonetheless, this ratio governs the flow of current because the charge is passing through a material. Now, this material is governed by many properties that we collectively call resistance. Let's further define resistance by looking at some of those properties.